All right, so let's look at the next example. It says complete the table shown to the right for the population growth model for a certain country. So we have here 2006 population in millions, uh, 87.2, projected 2041 population, we don't know, that's the unknown. This is what we want to find. And then we have the projected growth rate, which is 0.0075. So recall our model for exponential growth, which is A is equal to, or we can say f of t, uh, or A is equal to A sub 0 times e to the k times t. So let's identify some information that's given. Well, A sub 0, what did we say that represented in our model? If you want to go back to the beginning of page, excuse me, of section 4.5, we talked about what did each, the A sub 0, K, and T, what did it represent, as well as A, or we can say F of T. Well, remember this A sub 0 would be the value at the start, okay? Well, what was the starting population? That would be our A sub 0, which is 87.2, okay? Our projected growth rate, that's our K, and we have here 0.0075. Now, our time, now this is what we need to identify. Now, we do have the initial time, and that is, or the initial year, which is 2006. But we want to find out the population of the projected year, which is 2041. So we need to find the difference between those two in years. So we're going to subtract 2041 to 2006, and the difference is 35. All right, so we have everything that we need, okay, to fill in our information here for this formula. So we have A is equal to 87.2 times E to the 0.0075 times 35. And keep in mind it says round to one decimal place as needed. So when we enter this information into the calculator, we want to make sure we round at the end, not during the process. So let's go ahead and bring out the calculator, and we're going to put in 87.2 times, and then second and ln, which is the e to the power, and then we have 0.0075 times 35, and let's press enter. Okay, so we have here, you notice 113.375388, and we want to round to the one decimal place. So we have to look at the second 3 as we read it from left to right. And since the digit to the right is greater than 5, we're going to add 1 to the 3, and we have here 113.4. So the projected 2041 population is 113.4 million. That is our solution. Okay, let's look at the next example. We have here an artifact originally had 16 grams of carbon 14 present. The decay model, A is equal to 16 times e raised to the negative 0.000121 t, describes the amount of carbon-14 present after t years. Use the model to determine how many grams of carbon-14 will be present in 7005 years, or 7005 years. All right, so the model was given. A is equal to 16 times e to the negative 0.000121 times t. So what we need to find out to complete this model, because it's asking us, use the model to determine how many grams, we want to find grams of carbon-14 will be present in 7,005 years. So we're going to let t represent the, of course, our time, which will be 7,005 years. So we're going to put this information into our formula. 16 times e to the negative 0.000121 times that 7,005. And what does it say? It says round to the nearest whole number. All right, so let's go ahead and pull our calculator back out and let's put this information in. We have 16 times, let's go second and ln, and then we have negative 0.000121 times 7,005, and let's press enter. So we have here 6.85503708, and we went around to the nearest whole number. So let's look at the 6. Okay, look to your right. 8 is greater than 5. Therefore, we're going to add 1 to the 6. So we have 7. So the amount of carbon-14 present in 7,005 years will be approximately 7 grams. Okay, so that was our example here. Our last example on this page here, it is noted, it says use the formula T is equal to ln of 2 all over K that gives the time for a population with a growth rate K to double to answer the following questions. The growth model A is equal to 3 times e raised to the 0.002 times t, describes a population we call A of a country in millions and t years after 2003. It says what is the country's growth rate? So let's look at the formula that is being described here. A is equal to 3 times e to the 0.002t. So it says, what is the country's growth rate? So remember, K represents, when it's positive, it represents the growth rate. So our K here is 0.002, but it wants us to represent it as a percent. So convert 0.002 from a percent as a percent, or from a percent to a from a decimal to a percent. So 0.002, move 2 spaces to the right, becomes 0.2%. So this is our answer for part A. Okay. Now part B, it is asking us how long will it take the country to double its population. So we're going to use the formula that's given that gives the time for a population with a growth rate k to double. Okay, so let's answer part B, where we have t is equal to ln of 2 all over k, and t is equal to ln of 2 all over, what did we call k here from our growth rate model, 0.002. And we're going to round to the nearest year um, for this question here. So let's go ahead and use our calculator to input this information into the calculator so we can find our solution. So we have ln of 2 divided by 0.002, and let's press enter. And we have here t is equal to 346.5735903, and round to the nearest year. So we're going to look at the 6, and we have 5 or greater, so we're going to add 1 to the 6, and this gives us 347. So how long will it take the country to double its population? That will be 347 years.